Good day, everyone. Our topic for today is about motor control with PLC application. Here is the complete overview for programmable logic controller. We have the input devices here going to the PLC and going to the output devices. Now, the PLC can be programmed using a PC. Here in the personal computer, we can make the ladder diagram and the HMI. So what is a motor controller? A motor controller is a device or group of devices that serves to govern in some predetermined manner the performance of electric motor. It might include a manual or automatic means for starting and stopping the motor, selecting forward or reverse rotation, selecting and regulating the speed or torque, and protecting against overloads and faults. The basic function of a motor controller is to protect the operation of a motor. We have the types of control operation. 1. The manual control operation. It is a control that is considered manually operated when someone initiates an action for the circuit to operate. Second is the automatic operation. While manual operation of machines are still common practice, many machines are started and stopped automatically. Frequently, there is a combination of manual and automatic control. A process may have to be started manually but may be stopped automatically. Here is the disadvantages of the conventional motor controller. First, in a conventional motor controller, there are too many wirings. Modification, repair, and troubleshooting can be quite difficult. Also, there is a high power consumption in the conventional motor controller, and then longer downtime and maintenance and modification. Now we have the advantages of using the programmable logic controller. First, using PLC, it is more flexible. Faster response time, less and simple wiring, solid state for there is no moving parts, modular design, it is easy to repair and troubleshoot. Also, PLC has lower costs or less expensive. It will also increase the reliability and with communications capability, for we can control the PLC via remote, or we can switch on and off the motor through a remote equation by only using an RPU or remote terminal unit in a communication. Now what is programmable logic controller? A PLC consists of a central processing unit containing an application program and input and output interface modules, which are directly connected to the field I/O devices. It is a specialized computer used to control machines and processes. It uses a programmable memory to store instructions and specific functions that include on and off control, timing, counting, sequencing, arithmetic, and data handling. Now we have here the block diagram of a programmable logic controller. We have here the signals from the switches, the push buttons, sensors, and etc. going to the input module, and then it will be processed through the CPU, and the output here from the output module will go to the output devices such as solenoids, motors, and etc. Now the CPU here is connected to the personal computer or programmer console. Here in the computer, we can make or create a ladder diagram for the process, or we can also edit, modify, and troubleshoot the ladder program here. Plus, here in the maintenance PC, we can create the human-machine interface. Now, what is a control system? From the picture here, we can see that a control system is a collection of electronic devices and equipment which are in place to ensure the stability, accuracy, and smooth transition of a process of a manufacturing firm. We have the input devices, sample of which are the push buttons, toggle switches, pressure switches, limit switches, and sensors which are interfaced through the PLC input module. Here is the input module. Now, the input devices are wired here. For example, we can use this one as the start push button, the stop push button, and from the other sensors. These are field wiring from the devices wired to the input module. Now, we have the output devices, sample of which are motors, solenoids, pilot lamps, and etc. Now, the output devices are wired from the output module. As you can see here, from the output module, it will be wired to the output devices such as the solenoid, the pilot lamp, motors, or magnetic contactors, or relay coils, and etc. Now we have heard the PLC input-output wirings of the various devices from the input modules, input devices going to the input module, PLC to the output module going to the output devices. So this is the complete wiring in a PLC or programmable logic controller. Now we have the conventional motor and control circuit shown. This is the simple and mostly common wiring for the conventional start-stop motor. We have here the motor circuit and we have here the control circuit. Compared to the conventional, we have the PLC wiring circuit shown. Same, the motor circuit is the same as the conventional motor circuit. And then we have here the input devices. These input devices are wired or terminated to the input module here. And then we will make a ladder diagram, or we will make a ladder program here using the CX programmer for Omron PLC. After that, it will be processed and the output of the ladder program or the outcome of the ladder program, it will be processed and will go to the output module here and terminate here going to the output devices. Now we have here the equivalent ladder diagram for the start, stop, push button. So basically, this is the conversion from conventional wiring to PLC wiring. First, we have the conventional start-stop push button compared to the PLC wiring. As you can see here, the motor circuit in the conventional wiring and the motor circuit here in the PLC wiring is the same. The only differ is in the motor and the control circuit here compared to the control circuit here, which is in the input module of the PLC. But they are almost the same because, as you can see, we have here a stop push button compared to the PLC, which we have also a stop push button wired here going to the input module. Also, we have here the start push button and the start push button also here for the PLC wiring. Then we have the output here in the PLC wiring, which is the magnetic contactor coil. Now, similar to the conventional wiring, which is the output is also here the magnetic contactor coil connected to the thermal overload relay. Here in the PLC wiring, the contact for the overload relay is in series wiring from the magnetic contactor coil. The only difference is that here we have here a maintaining contact from the magnetic contactor coil, or we call the seal-in contact. It is wired here in the conventional motor control circuit. While in the PLC wiring, it is located in the ladder diagram here. Now, the equivalent ladder diagram for the start-stop push button is this one. We have here the stop push button, we have the start push button, and then this one, the seal-in contact or maintaining contact from the magnetic contactor coil. We have it here on the ladder. For this is the output in the ladder diagram for the output relay. So this is the output coil and this is the contact from the coil. So if we are going to put that into the 6 programmer of Omron, this is the equivalent Omron 6 programmer ladder diagram. We have here the stop push button, the start push button, and the seal-in contact from the coil or the coil of the output relay. This is the coil and we use the contact from the coil here for the seal-in contact. So as you can see, this ladder diagram for the 6 programmer is somewhat similar to the conventional and ladder diagram. For here, we will assume that this side is a positive and this side is the negative. A red line, vertical line here is shown if we have an open circuit or if we did not complete the circuit wiring here on the ladder program. Since we don't have the red vertical line here, it is clearly seen that our circuit here on the 6 programmer ladder diagram is correct. Or we have a contact start here in series with the stop push button going to the output coil or output relay coil. Now I have here the simulation for the start-stop manual. For we are going to use this using a push button start for this start push button 1.01 equivalent address was put in here for the push button for the start. Likewise, the stop push button 1.00 is the address for the stop push button here. Now, the output 11.00 will be used that address for the lamp here and the motor here. If we are going to simulate, the output here, once energized, this motor also will change the color and the color of the pilot lamp. So, okay, let's move on. Okay, the start push button is used from the 1.01 address, and then the stop push button address is 1.00. The 11.00 address was used in the maintaining contact and used for the output for the HMI. We are going to click the push button start. You will notice here the 1.01 that the contact 1.01 was closed, that energized the coil 11.00. Thus, the maintaining contact or the seal-in contact closed. You will notice that the motor and the pilot lamp change its color also. Now, the stop push button for the 1.00 is normally closed here. Once we push that one, the push button for stop, it will de-energize the coil for the 11.00 and the motor here changes back the color to the stop position or stop status. Again, the start push button 1.01, once we click the button, it will close the contact, energize the coil, and then the flow of current from positive to negative will run from the push button to the seal-in contact and energize the relay output coil. And when we stop, it will open the seal-in contact 11.00 for the 11.00 output relay coil for the motor was energized. This is the simulation for Omron PLC for the CX Programmer and CX Designer. I have shown you the complete ladder program and the HMI for the start-stop manual operation of the motor. Now, I will show you how to create the start and stop manual ladder diagram. So from here, we have the conventional wiring from this is the motor circuit and the control circuit. So from the conventional control circuit, we have the magnetic contactor and the thermal overload and the motor winding. Now we have here the supply for the control circuit of the start-stop motor. We have the start push button, the magnetic contactor coil, and the thermal overload relay. The coil here was used as a seal-in contact here in parallel with the start push button. Now, when we convert the conventional wiring to PLC wiring, it will be like this. Here is the PLC wiring, wherein the motor circuit is the same as on the conventional motor controller wiring. We have here the start and the stop push button, which are wired from the input, and the output modules wired to the coil of the magnetic contactor for the motor. So this is the hardware circuit for the PLC connection. Then this is the equivalent ladder from the PLC wiring circuit connection. This is the push button for the start. From there, the stop push button from the input devices, and then the seal-in contact from the output relay coil. Now I will show you how to make the ladder diagram here on the Omron CX programmer. Just click OK, and then this is now the window for the creation of the ladder diagram. We make a file name for our sample ladder diagram program. Say presentation 1. So going back to our wiring circuit and the ladder diagram, we will make it on the Omron CX programmer. First, we will make the stop push button. So we will select from the toolbars the normally closed contact, put an address to it. So put the address as 1.00, and then edit the command. We put the stop PD or the stop push button, and then click OK. Then we will make now the start push button. Put an address as 1.01 and label it as start push button. So that's the start push button there. And then now we are going to make the output relay coil. So connecting the lines there, and then creating the coil for the output relay of for the motor, and then address it as 11.00 and label it as output relay coil for the motor. Now we have here the complete circuit for the output relay, and now we are going to make the seal-in contact. So in parallel with the start push button. So we connect there the vertical lines, You notice the color red here once a circuit is not yet completed or if there is a modification that you are making in a RAM. This one is called RAM 00. So now we are making the serial in contact, so we will use the address 11.00. Now you notice that the seal-in contact is normally closed. Now this is not supposed to be closed. So we will edit that one using the right click and then invert nut. So the normally closed was changed to normal open contact, or we can delete the normally closed and get a normally open contact from the toolbars. Then now we will now connect to the simulator and check whether the ones we made here in the CX programmer for the start-stop program for the motor is working. So we force it on and you can see that a green color showing that the line is energized from left to right or from positive to negative. Now this is the start push button that we force on, and once we force it off, it will open. And of course, since the coil is already energized here, it will also close the contact here for the seal-in contact so as to have a complete circuit again, and continues the coil as energized. Now for the push button stop, here equivalent to that one, we will force also, and once we force it off on, then it will cut the positive from the left side going to the negative, and thus de-energize the coil here. And also, since this coil here is de-energized, the normally open contact that was closed before will turn to open contact. Now we are going to normalize again, so we will cancel all the forces that we made. Again, so we will force it on to show to you that from positive going to negative, the circuit is complete and it's working properly. And then we force it on, we stop, and that's it. So cancel all forces, and here, so this is where we make the ladder diagram for the start-stop push button for the motor controller or start-stop motor control using the Omron CX program. Now we are going to make the start-stop manual for the motor using the CX designer. So this is where the HMI interface are being created. This CX designer is used by Omron PLC. So here you can see here we are going to create a new project for the start-stop manual. Make a file name and then click OK. P00. Okay, now this is the creation window for the CX Designer human-machine interface, and this is where we are going to create the HMI for the start-stop push button. We can change the background here. Now we are going to click and drag a push button from the library, and there you go. We have now our first push button. It is momentary, and then we will put the address. So we will use the address 1.01 for the start push button. Now we are going to set the address 1, and then there you go, 1.01 for the address, and label the push button as start. Then click apply and OK. Now we have the push button labeled as start. Here are the sample shapes from the library that is already embedded on the CX Designer. So we are just going to select which push button, color, or design that we want to use. So it is up to the designer to choose which color he wants. So when designing an HMI, it is important that the designer should be creative so as to have an output HMI which is quite presentable also for other people. There we put the 1.0 address for the stop push button. Apply. Then now we are going to make the bit lamp or the pilot lamp. Here we can select the lamp type that we are going to use. Now the address for the pilot lamp, the output is 11.00. So we're now going to input the address for the lamp as 11.00. Click apply. line. So when the pilot lamp is on, it is colored yellow, and when the lamp is off, it is colored gray. So now we have the start push button, stop push button, and a pilot lamp. Now we can also make another design for the output, such as a motor. So here we will put again an 11.0 address, and then we will change the pilot lamp to other design, such as a motor or a pump, solenoid, etc. So now we are going to select an output design from the library. So you can shift the types. There you can see there are so many already pre-made design from the library. So we will just select. There is the shown are the blowers, which we can use, the pumps, the valves, the hopper, and the pipes. So these are some of the which we can use. So all we are going to do is click and drag it to the creation window. For the pump, we will choose the color gray, or we can change it out again to other design. So now we are still continuing selecting and choosing. So it depends on the designer which one to use. So there we will choose another output device is the actuator. Okay, so we can choose the actuator there. So the color gray when it is in the off position, and then the dark colored actuator or motor for the on shape. So there are two colors there, the gray and the black. Now once we click OK, it will be transferred here in the creation window. Now we can test it. First is saving it, and then now we are to start testing offline. Here in the testing offline, we can start checking the push button that we made, if it is working. Exit in the test mode, and now we are ready to connect it to the 6 programmer, or we are going to connect it online with the 6 program. So saving it again, yes to all. Now we are going to connect to the CX simulator. Click start, and then wait for it to download the program to the CX simulator. And now we have here the HMI interface for the start stop motor. So shown here the HMI interface, the start push button is here at the equivalent for the 1.01 push button. The stop push button is also here on the stop, and then the output 11.00 will be for the HMI. Clicking the start push button will energize the coil, and stop will then energize also the coil. So this is now the correct, and we successfully communicate it online, or design from the CX designer to the CX programmer using the FarmRun CX simulator. Okay. Now, I'm sure you notice or you know this person. He is Steve Jobs, and he once said that you have to learn continually, for there's always one more thing to learn. Now, for the Q&A, if you have some questions, you can raise it on a chat box or raise your hand, and I will answer it to the best of my knowledge. If not, then thank you and good day.